Hello, grade 7. Today I'm going to continue the explanation of chapter 1 in chemistry called states of matter. I'm going to start recalling what are the states of matter, and then we're going to move on to the classification of states of matter. So just to recall, what is a matter? A matter is anything that has mass and occupies volume. So matter is all around us, and it can be classified according to its state, properties, or its components. So as you can see in the picture, we're going to study 4 states of matter: solids, liquid, gas, and plasma. For the solid, all of you know what are solids: anything that has a specific shape and volume. And if you look deeply in any solid, you're going to see that the particles making this solid are very close together. So the atoms or particles are closely arranged and cannot move. While in liquids, a liquid has an arrangement of particles that are close together, but the particles are free to move because their force of attraction between the particles is weaker than it is in a solid. So if I compare the force of attraction, it means the force between two particles or more. It is higher in solids than in liquids. That's why liquids can move, they can flow. That's why also we call them fluids. In gas, you're going to see that the particles are randomly arranged and they are very far from each other. That's why we say that there is no force of attraction between them and gas can move freely. This is a picture showing you the difference between solid, liquid, and gas. You can see that in solids, the particles are closely packed. A solid has a fixed shape and a fixed volume. While liquids, of course, they're fluid. They can flow, they can move, they do not have a fixed shape. So they take the shape of a container, but they have a fixed volume. While a gas doesn't have a fixed shape and doesn't have also a fixed volume. The gas can take the volume of any container. The last state of matter is plasma. What is plasma? Plasma is the structure of a gas when it is heated to very high temperatures. Heated gas atoms are broken apart into negatively and positively charged particles. So when you heat a gas at a very high temperature, the atoms of this gas will break apart into particles that are negatively and positively charged. Where can I see plasma? I can see it in the universe, in the sun. So plasma are the most common state of matter in the universe, comprising more than 99% of our visible universe, and most of that not visible. But it exists in only a few kinds of places on Earth, like neon or fluorescent light bulb. Now I'm going to classify matter. How can I classify a matter? A matter can be classified according to if it's a pure substance or a mixture. What is the difference between a pure substance and a mixture? Let's look at pure substances. A pure substance can be an element or a compound. Elements are all the elements found in the periodic table. I'm going to show you the periodic table now. Okay, we have a lot of elements. Every single element is made up of one atom. So when I say oxygen, let's say, it is an element. It's one atom of oxygen. When I say hydrogen, it's an element. When I say sodium, it's an element. But what is the difference between element and compound? Compound is when you join many atoms together, when you do this bonding between many atoms together, such as water. Water is made up of, the molecule of water is made up of 2 hydrogen and 1 oxygen to make H2O. Table salt, same thing. It's made up of 2 atoms, sodium and chloride, so it's NaCl. So when you join together 2 or more atoms with chemical bond between them, it is called now a compound. But pay attention, compounds are pure substances. They're not mixture, okay? Even if I'm joining 2 atoms together, such as in water, H2 with O, it remains a pure substance, because if you look at the water, inside of the water you have everywhere this molecule of H2O repeating itself. So I'm not mixing 2 different substances. I'm just binding 2 atoms together to form one molecule or one compound. Now you have to make the difference between a pure substance and a mixture. So a mixture, from the word mixture, it means I'm mixing two or more different pure substances together. I have two types of mixtures. If you can look at this picture here, you can see that I have something called heterogeneous mixture and something called homogeneous mixture. Let's start with homogeneous mixture. If you look at the homogeneous mixture here, you can see that the particles are the same throughout with identical properties everywhere in the mixture. While if you compare it with the heterogeneous here, I can directly see that the purple color is taking the top portion of this container, while the green color is taking the bottom portion of this container. So if I look at the homogeneous, I can see green and purple everywhere. Okay, so a homogeneous mixture have one phase and uniform composition, and I cannot separate it easily. It's also called sometimes solution. I'm going to give you examples so you can understand what is a homogeneous mixture. Air is a homogeneous mixture. In air, I have a lot of pure substances. I have a lot of elements mixed together, but I cannot separate air. I cannot separate these elements. Okay, it's difficult to separate them. Sugar dissolved in water. When you dissolve something in water, such as sugar or salt, you cannot see it anymore. So I can see one phase, which is water, but in this water I have sugar dissolved. That's why I say it's a homogeneous mixture, because I cannot separate the sugar from water physically or easily. Steel is example of homogeneous mixture because you can see one phase. The milk in this picture, I can see a cup of milk. Milk, it's water plus milk dissolved in it, milk powder dissolved in water. So I can see one phase, but if I look deeply in this mixture, I can see that it's made up of water and milk, but I cannot separate them easily. While a heterogeneous mixture, it has more than one phase, and each component is exhibiting its physical and chemical properties. And it's easily separated. When I say easily separated or physically separated, it means I can separate it manually. Examples, pizza. You can see a lot of stuff in pizza, so it is a heterogeneous mixture. You can separate the onion from tomato, from corn. Another example is ice and soda, or salad dressing, or mixed nuts, or cereal and milk. You can separate the cereal from milk easily. Another example is oil and water. You can see here that when I put oil and water, the oil remains on the top because it's less dense. So these are examples of heterogeneous mixture. So keep in mind that a homogeneous mixture is made up of, or I can see it as one phase, while heterogeneous mixture, I can see two or more phases in it. And pay attention, this is a table showing you the difference between pure substance and mixture. A pure substance can be an element or compound. Element, it means one atom. Compound, it means many atoms joined together. And a mixture can be homogeneous or heterogeneous. A mixture is made up of many pure substances. A homogeneous mixture is a mixture where I can see only one phase, such as water or milk, while heterogeneous mixture is where I can see two or more phases, such as pizza or salad. So this is a table of differences between pure substance and mixture. You can see that we say for pure substance, it cannot be separated into two or more substances by physical or mechanical means, since it's made up of one element or one compound, while mixture, it can be separated into two or more substances because it is made up of two or more substances. Pure substances are always homogeneous. I always see one phase, while a mixture can be heterogeneous or homogeneous. Pure substances, its properties are constant throughout the whole sample, while mixture displays the properties of the pure substances, making it up. So inside of a pure substance, I have only one element that it has its own properties, while in mixture, I have many elements, many pure substances in this mixture, and each pure substance is exhibiting its chemical and physical properties. And that's it for today. You have just to memorize your notes. What is the difference between pure substance and mixture, and how can I classify it?